Good morning. Today we're going to start talking about the information in Chapter 2. This chapter begins with dealing with early atomic theory. Please make sure that you remember the names in this part of the chapter because these names are going to be asked for on the test. Make sure you know the scientist's name. Make sure you know also what they were responsible for discovering. So, in the beginning of this chapter, we start with looking at the scientist Democritus. And Democritus was actually the first scientist who actually came up with the name for the smallest part of matter or atoms. He called them atomos. And that term actually means indivisible because he thought the atoms could not be divided into smaller parts. That's how we get the name. After him came the philosopher Aristotle and others who believed that all matter was made up of four elements, but they never experimented to find out any information about those four elements. So, you've probably heard of the name Aristotle before. Aristotle is known in a lot of fields, but just because you've got your hand in a lot of fields and you do really good work in some fields, that does not always mean you're right. Okay, so don't just accept things as correct because somebody else told you those things. Please make sure you verify. Then we move on in the early 19th century to John Dalton. And John Dalton came up with his 5-point plan. Now, there are aspects of his plan that we know are absolutely true. He did not necessarily know at the time, but he made some suppositions about some things, and he stated things again that we now, based on experimentation, know is absolutely correct. There were also some assumptions he made, though, that were incorrect. One of those being that he thought that atoms were indivisible, just like Democritus. However, we now know that that is incorrect. He also thought that atoms of the same element were exactly the same. We also now know that that information is correct. But everything else about his 5-point plan was absolutely correct. Please make sure you consult your textbook and see what those 5 illustrated points are there for you so that you can get a better understanding of what his plan was. After John Dalton came J.J. Thomson. J.J. Thomson's model was called the plum pudding model, and he detected the subatomic particles using a cathode ray tube. The first subatomic particle he found was the electron because that negative of the electron was attracted to the positive from the cathode ray tube. His model again is called the plum pudding model. If you were describe the plum pudding model, plum pudding is not something we generally eat in the United States. They do in Europe, but for us in the United States, if you'll think about it as like the chocolate chip ice cream model, if you think about what chocolate chip ice cream is, how you've got the vanilla ice cream, and mixed up in that vanilla ice cream, you've got chunks of your chocolate chips. That's kind of what the plum pudding model was. He thought that those electrons were distributed just randomly in the vanilla ice cream or the positive charge medium of the atom. And so, again, because he was able to figure there was an electron, he also knew that the atom was neutrally charged. So he also was able to figure out that there was a positive charge. He just thought that that positive charge was just the medium that those negative charges were dispersed in. We move on then to Robert Millikan, who did the oil drop experiment. And from that experiment, he was able to figure out the actual charge of the electron. And then that finally leads us to Ernest Rutherford. And Ernest Rutherford did the gold foil experiment that helped us find the nucleus of the atom. Okay? Now, again, what he expected as he shot alpha particles through gold foil. And what is gold foil? Well, the term foil just means a thin sheet of metal. So he had a thin sheet of gold and he shot it with alpha particles. And he was expecting that, based off of what J.J. Thomson said, that these alpha particles would travel straight through the atom. However, what he found was that all of those particles did not travel straight through the atom. Some of those particles hit something solid in the center of the atom and were deflected. Some of those other alpha particles actually hit something and were reflected, or they were knocked off their path. Some of them actually came back at the detector, and then most of them just went straight through. But because some were deflected and some were reflected, he was able to figure out that there was something solid in the center of the atom. So again, please, please, please make sure that you look at these models that they have shown you pictures of in your textbook. That'll give you a better understanding of what these early scientists said. Now, again, these scientists' names you will be questioned about. So make sure that you are able to pinpoint the specific scientist with their particular model. All right, that leads us to isotopes, which were actually found in the 1900s. So about 100 years after Dalton had done his work, we were able to find isotopes. And again, isotopes disproved Dalton's theory that all atoms of the same element were exactly the same. Now, in 1932, Chadwick was the first scientist who actually found some evidence of neutrons. And if you remember, neutrons are actually uncharged particles that are found in the atom. They're actually smaller than the atom. They're actually specifically found in the nucleus that was found by Rutherford. Because they are uncharged, it was very difficult for them to be found, which again is why they were not discovered until 1932. However, Chadwick was able to determine that they had about the same mass as the proton and that they were also found in the nucleus. So these names, again, are the names that you need to be familiar with for early atomic theory. Once you get these names down, in the next video, we'll talk about atomic structure and how these subatomic particles are organized in the atom. Until then, hope you enjoy the rest of this chapter.